The factory manager asked me to look at improving the capacity of a bottleneck equipment set. How do I do that in TooCool?
Overall equipment efficiency is a useful metric for measuring productivity of an existing installed base of bottleneck and near bottleneck equipment. Since overall equipment efficiency is a subset of cost of ownership, it is possible to measure the impact of both cost of ownership and overall equipment efficiency in a single TooCool model. So what is overall equipment efficiency? While not completely accurate, it is the percentage of time the equipment is doing what it was intended to do. To examine the overall equipment efficiency data, we'll open your previous model and select the Input OEE Input menu command. By selecting OEE Input, you will be presented with a 3-tab input form for access to those input factors affecting overall equipment efficiency and the consolidated output information. The OEE input form allows you to select availability, performance, and quality. Current values for each section are pre-populated from the model you completed previously. Additionally, calculated outputs are displayed at the top of the window. These values are dynamic and reflect changes made to any of the input fields once the Update button has been clicked. Since overall equipment efficiency is a subset of cost of ownership, any changes made on this form, except for theoretical throughput, will impact your cost of ownership results as well. Clicking on the Undo button will reset all previous values. Let's take a look at where there are opportunities for improvement in overall equipment efficiency. The Availability Inputs tab provides you access to scheduled maintenance, mean time between failure, average response time, mean time to repair, mean time between assist, and mean time to assist. Some factors that impact availability also impact the performance calculations and are included on that tab. We can use sensitivity analysis to measure the impact of these factors on overall equipment efficiency. On the Availability tab, let's examine scheduled maintenance to see if reducing it by 50% has a significant impact. As you can see, that has no real effect on overall equipment efficiency given all the other data. The Performance Inputs tab provides access to throughput at capacity, theoretical throughput, engineering usage, standby time, production test scheduled, mean time to test, weekly production hours, and shifts per week. The theoretical throughput input is the only input that is unique to overall equipment efficiency and is not used by cost of ownership. Certainly, improving the throughput would be a good way to increase capacity, if that's possible. Let's run sensitivity analysis to see. As you can see, the loss of throughput compared to the theoretical throughput is causing a loss of about 10% in overall equipment efficiency. I suspect that only running the equipment for 2 shifts per week is a real impact. Let's see. Each additional shift adds about 15% to overall equipment efficiency. That is likely the biggest factor in improving overall equipment efficiency. But can your company sell all that extra capacity? The Quality Inputs tab provides you access to equipment yield, defect density if you are in the wafer fab mode, die area, again in the wafer fab mode only, fault probability in the wafer fab mode, clustering parameter also in the wafer fab mode, parametric limited yield loss, and redo rate. Yield and redo rates can have a large impact on capacity. We'll start by looking at equipment yield. Since equipment yield is so good already, there isn't much room to improve. But what about parametric yield loss? Again, the available improvement is small. Lastly, let's look at redo rate. Again, there isn't much improvement. So, in this case, in order to improve overall equipment efficiency, you would start by asking equipment engineering why actual throughput is 25% below theoretical. After that, you would need to examine a larger number of small improvements or consider adding an additional shift. One last point. 2 additional buttons are at the bottom of the form to allow direct access to the overall equipment efficiency report and chart. The chart can provide a good starting point to identify large areas of losses. As you can see in the chart, the largest block is non-scheduled time, followed by rate efficiency, which is really throughput. Overall equipment efficiency is an excellent tool to improve the performance of bottleneck and near bottleneck equipment sets. Increasing capacity of other equipment sets is likely a waste of time and money, as their extra output will be constrained by the bottleneck equipment. Combining overall equipment efficiency with cost of ownership will allow you to determine if those overall equipment efficiency improvements are cost effective.